Okay, this is Calculating Parallel Circuits, page 2, question 8. First thing, don't get too concerned about your numbers in here. They don't matter because the numbers, the process is the same. Doesn't matter what the numbers are. So we'll figure it out no matter what your numbers are. You can still figure this out. First thing to remember is our formula for Ohm's law, which is voltage over amperage times resistance. So whichever one I am trying to figure out, I cover up, and that's the formula I'm going to use. So things I do know about this circuit and things I don't know about this circuit are, currently my voltage is unknown. I don't know what it is. What I do know in this circuit though is that I have one resistance. I have two, one here and one here. I have two resistance. So resistance 1 and I have a resistance 2. I know resistance 1 is 6 ohms. Resistance 2 is still unknown. For amperage, for resistance 1, so my amperage for resistance number 1 is 1.33 amps. And my resistance for 2 is unknown. Okay? But I do have extra information is that I got a total resistance for the whole circuit. So my resistance total equals 2.67 amps. Okay? So I have that. So if I look at here, I get some information as well. Each branch of a circuit receives source voltage. So it doesn't matter, it doesn't make a difference where in the circuit voltage is going to flow equally across everything. So if I know voltage, I can figure out the rest. The total current is equal to the sum of the current flowing through each branch of the circuit. So if I add them up, if I add up this number here and this number here, if I subtract this from this, I'll get what the amperage is on this one. Okay. So let's calculate voltage first. So V is I, so I need I times R. So if I got V equals I times R, I know that I, if I'm looking at this circuit right here, I know that resistance 1 is 1.33 times my resistance here, which is 6 ohms, which equals 7.98 volts. So my voltage over here is going to be 7.98. That's constant through anywhere in that circuit. Okay. So if I want to now figure out what my current flow in this one resistor is, I can do that by taking my total resistance, which is I equals 2.67 amps. That's my total. And I also have this one right here, which is 1.33, which is my current in my resistor number 1. Because these two resistances, this guy and this guy, will create a voltage drop because of the resistance inside the circuit. So if I know that my total is this, and if I subtract this, I should get the remainder. The remainder is going to be this guy right here. So if I take 2.67, get rid of this for a sec. If I take 2.67, that's my total average in the circuit, and I subtract 1.33, which is the one I know, I'm left with 1.34 amps. So that means then this right here has to be 1.33 amps in resistor 2. So resistance 2 the current flowing through that guy is that. Okay, so now I can fill in the blanks over here, and I do know two more things. I know I have 7.98, and I also do know that I have 1.34 amps here. Okay, I made a mistake right there. It's supposed to be a 4, right? So now that I have that information, if I'm looking for R2 still, so resistance 2. So what is my resistance here? Now that I know this, and I know this, I'm still looking for resistance. So if we go back to my formula again, resistance equals V over I, and I know that my V is 7.98 volts, and I know that the current I'm talking about is 1.34 amps. If I calculate that, I should get 5.96 ohms of resistance through R2, which is really close to R1. But if I look at my current through R1, it's 1.3, and the current through R2 is 1.34, which is almost identical. So that makes sense that the resistance will be very close as well. That's how I do that question.